day everyone! Welcome to Project M Squared. I am Sir JC, your guide in making math easy. For today's video lesson, we will solve word problems involving permutation where n and r are needed to be solved. This video is guided by the most essential learning competency of solves word problems involving permutation and combination. On the previous video, you have learned how to apply fundamental counting principle and permutation in dealing with arrangements which require some conditions. But what if the value of n and r are now asked? How can we derive equation for n and r? Those questions will be answered in today's video lesson. So brace yourself and get ready to learn new things with this new episode. Let's start with solving the value of n. Number 1. In a contest, there are 24 ways to choose the winners of the champion, the first runner-up, and the second runner-up. How many contestants are there? You can pause this video and able for you to answer this at your own pace. Since this problem involves arrangements, this problem deals with permutations. By analysis, the number of ways to choose a winner, which is 24, represents the value of permutation of n taken r, while the number of winners declared, which is 3, represents r. In this scenario, we are asked to solve for the value of n. To solve for its value, we will use the equation permutation of n taken r as n factorial divided by the quantity of n minus r factorial. Furthermore, we will use the definition of factorial itself. Substituting the given values, the equation becomes 24 is equal to n factorial divided by the quantity of n minus 3 factorial. Enable for us to solve for the value of n, we must eliminate this factorial symbol. To do that, we will use the definition of factorial notation. N factorial means the product of positive integer less than or equal to n. So following that definition, we can express n factorial as the product of n minus 1, n minus 2, and n minus 3 factorial. I stop expressing the product at n minus 3 factorial because n minus 3 factorial will be cancelled out eventually because of the divisor n minus 3 factorial. Cancelling n minus 3 factorial at the right side of the equation becomes 24 is equal to the product of n minus 1, and n minus 2. Continuing the process of solving n, we will multiply the right side of the equation. N times n is n squared, n times negative 1 is equal to negative n, and that is multiplied by n minus 2. N squared times n is equal to n cubed. Negative n times n is negative n squared. N squared times negative 2 is equal to negative 2n squared. Negative n times negative 2 is positive 2n. Then, combining like terms at the right side of the equation becomes 24 is equal to n cubed minus 3n squared plus 2n. Then, we will write this equation into standard form and equate it into 0. 0 is equal to n cubed minus 3n squared plus 2n minus 24. Then, enable for us to solve for n, we will solve for the solution or the roots of this equation. Enable for you to solve for the roots or the solutions of this equation, you can use rational roots theorem or by factoring this equation. The complete factored form of this equation is equal to n minus 4 multiplied by n squared plus n plus 6. This is already the complete factored form of the equation. By using zero product property, we think of possible values of n that will make the right side of the equation 0. Given the factors, the only possible value of n which will make it 0 is when n is equal to 4. Because when n is equal to 4, this will become 4 minus 4 is equal to 0, and we know that any number multiplied by 0 becomes 0. In this case, the only acceptable solution for the value of n is equal to 4. So by checking, we evaluate permutation of 4 taken 3. That is 4 factorial divided by the quantity of 4 minus 3 factorial. By further evaluation, this will become 4 times 3 times 2 times 1 divided by the difference of 4 and 3 is 1, factorial is 1. So this will become 1. So 4 times 3 times 2 times 1 is equal to 24. Divided by 1, that is equal to 24. That satisfies permutation of n taken r is equal to 24. Therefore, in the given contest, there were 4 contestants, and 3 of them were declared as winner. Did you get the value of n correctly? That's great! Let us now proceed to the next part of this video, which is solving the value of r. Among the 9 contestants, there are 15,120 ways to choose the winners. How many winners were declared? Again, you can pause this video and enable for you to answer these at your own pace. Let's now answer. This given problem involves permutation. By understanding the given problem, we know that the value of n is equal to 9. And the value of permutation of n taken r is equal to 15,120. The problem asks for how many winners were declared. This implies that we need to solve for the value of r. We can do this by deriving and manipulating the general equation for permutation of n taken r. Remember, permutation of n taken r is equal to n factorial divided by the quantity of n minus r factorial. By substituting the given values, permutation of n taken r is equal to 15,120. That is equal to the value of n is equal to 9. That is 9 factorial divided by the quantity of 9 minus r factorial. Our goal is to solve for the value of r. And to do that, we must need to cancel out this factorial notation. To do that, we are going to use multiplication property of equality and multiply both sides of the equation by the quantity of 9 minus r factorial. In that case, we can cancel out 9 minus r factorial in the denominator. That becomes 15,120 is multiplied by the quantity of 9 minus r factorial, and that is equal to 9 factorial. Remember, our goal is to isolate the value of r. We will divide both sides of the equation by 15,120. Canceling 15,120, what remains to the left side of the equation is the quantity of 9 minus r factorial. 9 factorial has the evaluated value of 362,880. And that is yet to be divided by 15,120. The quotient of 362,880 and 15,120 is equal to 24. So the equation becomes 9 minus r factorial is equal to 24. To cancel out this factorial symbol, we must express 24 as factorial notation. We can express this 24 as 4 factorial since 4 times 3 times 2 times 1 is equal to 24. So this 24 will be written as 4 factorial. The equation becomes 9 minus r factorial is equal to 4 factorial. Then, factorial symbol will be cancelled out. The equation becomes 9 minus r is equal to 4. We can now remove the grouping symbol, and you can use property of equality to manipulate and solve for the value of r. Using property of equality, the equation becomes and by further evaluation, that is r is equal to 5. Therefore, there are 5 participants who were declared as winner. Indeed, this solution is very long and requires mastery of properties of equality to manipulate the equation correctly. But do not worry, you can solve for the value of r using trial and error. Remember, r can be understood as the number of positive integers less than or equal to n to be used as factors. By that definition, we can just multiply integers less than or equal to 9 and find out how many factors will arrive at the product of 15,120. To do that, since n is equal to 9, we start with 9 as a factor of 15,120. Nine times 8 is not equal to 15,120. So we multiply it again by integer less than it. The next positive integer is 7. But the product of 9, 8, and 7 is just 504. Remember, our goal is to have a product of 15,120. Suppose you continue this factors until 5. If you check the product of 9, 8, 7, 6, and 5, you will see that the answer is 15,120. As you can see, the number of positive integers less than or equal to 9 which was used as a factor is 5, which is the same as our answer in our long solution. So therefore, R is equal to 5. Did you get the same answer? That's awesome! Continue practicing manipulation of equation to be ready for even challenging problems like this in the future. I hope you learned something from this video. Again, this is Sir JC reminding you, math is easy when you perceive it positively.